We're going to look for two sides that both have numbers written on them in the same place. So we'll look at 36 versus 27. I'm going to put 27 on top. So I'm going to call this shape my top shape, and the other one would be my bottom shape. So if I pull 27 out, I'm going to say 27 over 36. But a lot of times it's just easy to simplify. You don't have to. By all means, if you're not good at simplifying, you can use it as such. You just come up with a lot bigger numbers. Can someone tell me what this simplifies down to? Right?
3/4.
3/4. All right, so all of our pairs need to be proportional to 3/4. So let's use 3/4 here. Let's use 3/4, and this is my top, and this can be my bottom. So the first thing I want to look for is RA. Well, RA is right here. Well, I don't know that length. That one's a mystery to me. But I do know that OG equals 42. And since that's my top, we'll do 42 over RA. And I can just leave it as RA, or I could change it to X, whatever I want to. All right, then we're going to use cross multiplication. Let me put that in red. Or the means extremes exchange. And that's going to give me, well, 3 times RA is going to equal 4 times 42, will be 168. And then I would just divide 3 on both sides. Well, that should have gave me RA equals 56. Yes, 56. Okay, other one is, well, we're still going to use, that's why we find this guy, because we're going to use them throughout, that 3/4. So I'm going to say 3/4 equals, and the last thing I need to find is WG. WG. I don't know what WG is. And that's for my top, so I'm going to put WG on top. On the bottom, I'm just going to put that side that relates to it, so that's 40. We're going to use cross multiplication, so I'm going to have 4 WGs. That says GGs. Let's actually put WG. That's going to equal 3 times 40. I hope that equals 120. Well, if I divide both sides by 4, I'm going to find out that WG just equals 30. So was it the angle that you thought was a decimal?
Yeah.
Is that the one?
I accidentally used the proportion.
Oh, okay. But remember, if you shrink that, it'd be a smaller angle. Right? And think about that. It can't get smaller and smaller and smaller. Otherwise, you'd run out of stuff. Those angles are fixed in place. They have to be congruent. Similar means congruent angles, proportional sides. Okay? That's why we have that angle property. We have the side angle, side property. The angles had to be the exact same, have to be congruent. All right, that's going to lead us to an awesome parallel line proportionality theorem. So it's going to be another way we can check proportionality of sides and check to see if things are parallel, actually. So this theorem says a line is parallel to one side of a triangle if and only if it intersects the other two sides, dividing those sides proportionally. Proportionally. So up until now, if I wanted to get the proportion of A, I had to say A was congruent to this whole side, right? We'd said A would be over A plus C. Well, based upon this theorem, if I know these two lines are parallel, I can now say, well, A to C is the same proportionality as B to D. In other words, A over C has to equal B over D. Another way we could write it is we could say A to B, straight across, is the same thing as C to D. That falls under the umbrella of this theorem. The things that don't fall under this umbrella, I can't go A to D and B to C right now. Let's not go straight there. It is something we can work with, but let's not go straight there. The other thing this does not specifically cover is, I'm going to go ahead and name this L, and let's call this, I don't know, M. This proportionality theorem says nothing about the length of the line. All right? So what this theorem does not say, it does not say if I go A over C, that does not imply that has to equal L over M. This does not work. In this case, we'd have to go back to the A compares to the whole length. That would compare to L over M. All right, like we've been doing. This only works if I'm talking about the sides. Does not work when I'm talking about parallel. All right, that's important to remember. All right, because we have questions about that. All right, so that does not work. All right, then I also have a proof of it. I'm not going to really spend a whole bunch of time looking over it. I was going to go through it, but at the end of the day, just looking at it will be enough. Because I'm not going to ask you to do a 7-step proof like this because we haven't been working much on proofs in this section. All right, so I'm not going to put this on the test, but it's always good to know that it is true and there is a proof that supports it. All right, we're going to go to the back side. And we're going to use that theorem to basically help fill in these missing dots. So without having letters, without having variables, we're just going to talk about what can be compared and how it can be compared. So if I'm comparing my lower left to the whole left, right? So I'm comparing this lower left to the whole thing, and now I have the lower right on top. What needs to be underneath that? What needs to be underneath that for the proportion to be the same? Anna? Whole right. So the whole point of this is what I do to one side I have to do to the other side. If I'm comparing the lower left to the whole left, I need to have the lower right to the whole right. So I can't pick and choose. I can't say lower left, whole left is the same thing as lower right to top right. Can't do that. All right, so be careful of what you do on one side. All right, if I have upper left and lower left, what am I going to write in the other fraction? That'd be comparable. Yeah?
Upper right, lower right?
Yep, absolutely. Upper right. Lower right. All right, let's go to that bottom left one. I have upper left goes to whole left. Well, I'm going to do this one because it's pretty much the same thing as this one. This was lower left, so if it's upper left to whole left, it's going to be upper right to whole right. All right, this one says upper left to whole left. Remember, the only time I can compare parallels is if, in one of these fractions, I'm using the whole side. So this says whole left. All right, that is important. Yes?
Bottom parallel.
Maybe bottom parallel. I just put lower. But you could put bottom. But the key here is whole left. That's the most important part. Without that whole left, I can't compare it to the parallels. Can't stress enough how important that is to know. Because here I could do upper left, lower left, upper right, lower right, but I cannot do upper left, lower left to parallels. All right? Cannot do that with parallels. However you want to note that to yourself, it's important. All right, we can expand. We can expand this theorem to two different ways. The first way is, what if I have multiple parallel lines in a triangle like this? Well, then I can say that A to B is equal to C to D is equal to E to F. That's the easiest way to do it. Don't go too crazy with it where you're trying to compare A to E or something, or B to F. Just go straight across. That's the easiest way to do it with more than one parallel line. All right, we can also transfer this over to if I have three parallel lines, like here, and doesn't have to form a triangle. All right, I have two transversals just angled towards each other. Note, eventually this would make a triangle, but if I have three parallel lines cut by two transversals, and let's what numbers did I pick for these? I picked, so I wrote it like this. I wrote 15, 10, y, and 14. All right, 15, 10, y, and 14. So we need to put that here. Okay, with those three parallel lines, we can adapt that theorem to work with this. So we could say that 15 over 10 equals y over 14. Well, 15 over 10 could be simplified into 3 over 2 equals y over 14. Well, using cross multiplication or the means extremes, it'd be 2y equals 3 times 14 is 30 plus 12, which would be 42. So that means that y equals 21. So we don't even have to have a triangle to use this property. All right, it works with just three parallel lines. And if you notice, that's kind of how that theorem starts out. It doesn't start out if you have a triangle. It says, a line is parallel to one side of a triangle. So it starts out with a line being parallel. That's the most important part of it. Okay. So we got that. We got that. Now we're just going to do 2 or 3 quick problems. And there's multiple ways to do number 1. The first way I'm going to do it is I'm going to compare 36 to 42. So I'm going to set up the ratio of 36 over 42. What am I going to set that equal to? Right?
Well, I just simplified it down so that I divide them both by 6.
Oh, okay. And what does that come out to?
6/7.
6/7, okay. And what can I compare that to then?
30 being
The-
6 of it.
Yep, so 30 on the top.
And then A and
Oh.
A on the bottom.
Yep, over A. So if I did, basically this is kind of like our top right, top bottom, compared to our top left, top bottom. All right, so just stay in the same order, 36, 42, 30, A. And then it will work out. So we just got to cross multiply. So we're going straight across, straight across. I think I'm just going to come down here with it. So I'm going to have 6 times A. That's going to equal 210. And then just double checking. Yeah, it should come out to 35. A should equal 35. All right, let's say I did it a different way. Let's say 30 to 36, and I'll compare that to A over 42. So rather than going down, I'm going to go across. I'm going to go 30 divided by 36, A over 42. All right, notice I stayed on the same side. So this side was my top side, this side was my bottom side. All right, so if I simplified stuff, so I can come down here, well 6 goes into this 5 over 6 equals A over 42. If I cross multiply, I'm going to come up with 6A equals 200 and, didn't we already see 6A, 210? So it comes up with the exact same answer, right? It comes out with A equals 35. So there's multiple ways to do this, and they're all going to come out with the exact same answer. All right? Number 2. Think about it. Think about it. How can I set this one up to get my parallels? I'm going to give you a second to think about it. Mazen.
Since 72 is like, use like the bigger parallel,
Mm-hmm.
you can't use
Oh, great. Can I write that down? I'm just going to write down just exactly what Mazen said. Because we're dealing with the parallels, we cannot do 35 over 21 equals b over 72. We cannot do that. That will give us the wrong answer. So what do we need to do, Mazen, instead? I have to add them up. So if I'm dealing with parallels, you should be adding up a side. So that's going to give me 56. So rather than doing 35 to 21, we can do 35 to 56. And that's going to equal our b over our 72. Now did I simplify this? I did simplify this. So 35 over 56 simplifies down to 5 over 8. And if that equals b over 72, I do that cross multiplication. And we're going to see that 8b equals 360. And my b is just going to equal 45. And let me just say, if you did this method, if you did that top method and you went all the way through it, you'd come out to 120. You would say my b equals 120. Does b equaling 120 make sense? Does b equaling 120 make sense? If this is 72,
No.
would it make sense if this was 120? No. Does it make sense that it's 45? So do that spot check. Just make sure you did stuff correct. I mean, obviously, I don't know this 100% sure, but at least it works in this problem. 45 at least makes sense. 120 doesn't make any sense, so you knew you did something wrong. All right, that would have been a sign, wait, this is a smaller, it can't be bigger than this one. Do that spot check, because it can catch lots of egregious errors. All right, make sure your number makes sense in the drawing. All right, the last one says, is CN parallel to RW? And it says, explain. Well, in order for CN to be parallel to RW, that would mean the ratio from here to here would be the same as this ratio from here to here. So let's just set it up and check it. Okay, we're going to set it up and check it. So 24 to 28. That's one of my ratios. In order for these to be parallel, the other pair have to be proportional to it. So 24 over 28 has to equal 32 over 36. So let's simplify this. Let's go ahead and simplify this. Well, 4 goes into 24 6 times. And it goes into 28 7 times. All right, we're good there. What goes into 32 and also goes into 36? Yeah, 4 again. We just used 4. That's probably not going to be right. How many times does 4 go in 32? 8, okay. Uh-oh. How many times does 4 go in 36? Does 6 over 7 equal 8 over 9? No. So if that's not true, can they be parallel? No, not parallel. Not parallel, not proportional. Not parallel, not proportional.